I told you guys I would provide you with the solutions to the free response that we didn't have time to do in class. I'm going to try to do this quick. This was one we started, but we didn't have a chance to finish. So it's a collision, but we have to look at it from a force time graph. So we have a 2 kilogram cart at 3 meters per second colliding with a unknown mass cart that is at rest. We're given some information about what happens to the smaller cart after the collision, but without the mass, we can't really do much without first looking a little more at this graph. So force versus time, we know that the area under a force versus time graph is going to give us the impulse. And again, this just says the force versus time for the collision. So that means on this cart, the impulse is going to be positive, right, to the right, but the force acting on this cart, which is what we're looking at in part A, would be to the left. So down here, part A, calculate the magnitude and direction of the velocity. First thing we need to understand that the change in momentum of that cart is going to be equal to the impulse, which we just said is the negative area of that graph. And the change in momentum would be the mass times v final minus the initial. And then that area, if we calculate that, is 1/2 base times height would be negative 5 Newton seconds. Notice they give us kilonewtons and milliseconds, and we multiply. This would be times 10 to the third, and this would be times 10 to the negative third. So when we multiply them together, we get just Newton seconds. Okay, so when we calculate this out, then we can find V final. So that means divide both sides by the mass. This was a 2 kilogram object over here. Divide that by the mass. So V final then would equal, if we divide Newton seconds by kilograms, we get meters per second. Our initial speed there was 3 meters per second. So negative 2.5 meters per second minus 3 meters per second. Plus equals positive 0.5 meters per second. Okay, so that would be the speed of cart 1 using the impulse momentum theorem. Trickiest part about this is you have to recognize that we have to have a negative because we're talking about the impulse acting on car 1, which is equal and opposite to the impulse acting on car 2. And this graph that they're showing us doesn't really show the direction, so we have to know to put a negative there. Moving on to part 2 is the collision. So now we know that after the collision, we're told that this unknown one is moving at 1.6 meters per second that way. And then we also have just figured out that the first car is also moving that way at 0.5 meters per second. And if we go back, again, the fact that we got a positive value here tells us that the positive has to be to the right, right? We have to rely on our directions. These are vectors. That tells us that cart has to still be moving to the right. So if we write this out, the momentum before the collision has to be the same as the momentum after the collision. So that means 6 kilogram meters per second, right? MV for this cart plus 0 has to equal 1 kilogram meter per second. That's the momentum of this cart plus, and we don't know m, so it's plus m times 1.6 meters per second. So if I do the math here, 1.6, double checking. So if I do the math here, then I can subtract it. So I get 5 kilogram meters per second divided by 1.6 meters per second gives me whatever that comes out to be, 3 point something 3.1 kilograms. So that's really the only part of this problem that's strictly a conservation of momentum problem, and it's pretty straightforward. Once we know the velocity of cart 1 after the collision, then we can just apply conservation. Quickly on to the last parts, because this is really kind of some review, but it's good review. Number 1, here on this part, calculate the acceleration. So it's saying after the collision something happens. So we're not going to worry about the collision anymore. So what is the acceleration at 3 seconds, which occurs right there? Well, everywhere from, it looks like 2 to 3.5 seconds would be constant acceleration, because the acceleration is simply the slope. So it's just saying find the slope between 2 and 3.5 seconds. Looks to be somewhere around, I think, 0.73. So change in velocity over the interval there. So the final velocity at the end of the interval looks like 0.5 meters per second minus the initial looks like 1.6 meters per second. The time interval is 1.5 seconds. So the slope there is about 0.73 meters per second squared. And don't forget, it's a negative slope. Calculate the distance traveled. Distance traveled on a VT graph is the area under the curve. So the total area, we've got really 3 areas, 1, 2, 3. And if I just simply find the 2 rectangles and then the triangle, I can find the total distance traveled. So this is just area, and I think it comes out to about 5.5 meters or so. And then lastly, state whether the ramp goes up or down. I think that's kind of common sense. The fact that the cart loses speed right there tells you that the ramp has to go up, and calculate the elevation. So they're saying use conservation of energy. So MGH, right, the change in potential energy of the cart must equal the change in kinetic energy. So 1/2 m times delta V squared. Solve for H, cancel out the M's, do a little algebra. H comes out to, I believe, about 12 centimeters or so. Once again, these CD and E are great review for kinematics. So definitely worth your while getting close to the exam.